Hey, one more video. We're going to talk about the factor theorem. And Rose, all the factor theorem says is that if you divide two polynomials and the remainder is zero, it means the polynomial that you divided by is a factor of the original polynomial. So, with numbers, it's pretty simple, right? If you divide 6 into 18, you get 3 remainder 0. The fact that it's remainder 0 tells you that 6 is a factor of 18, right? If two numbers divide and the remainder 0, it divides in there perfectly. It's a factor. Okay. So the same thing works with polynomials. So number 10 on the class exercises says, hey, is x minus 3 a factor of 4x to the fifth minus 3x cubed minus 7x squared plus 12? You know what we do? We do synthetic division. If we get a remainder of 0, we have a factor. If we get any other remainder, we don't have a factor. So, the polynomial, let's write out the coefficients. It starts with 4x to the fifth, so I put down 4. By the way, I should probably start with this. We're dividing by x minus 3. So on the far left in a box, I would put a 3. Then let me start over. The polynomial is 4x to the fifth. That's a 4. I don't have an x to the fourth, so I'd put a 0. Negative 3x cubed means I just write down negative 3. Negative 7x squared means I write down negative 7. There's no x term, no linear term, so I put down 0. And the constant is 12. So just to reread what I have in my first row here, I get I got positive 3 in a box. And then I have the numbers 4, 0, negative 3, negative 7, 0, and 12. Again, I leave myself a little space below that, and I draw a line. And I just run through this algorithm for synthetic division, right? I bring 4 all the way down below the line. Use my multiplier of 3. 3 4s are 12. Add down. Second column says 0 plus 12 would be 12. The 12 now goes below the line. 3 times 12 is 36. We bring that up and to the right. 36 added to that negative 3 gives 12. 3 times 12 is 36. I'm sorry. I totally screwed up. Let me back up the bus here. The column before was negative 3 plus 36. That gives 33. And that 33, when it gets multiplied by 3, gives 99. So the fourth column has a negative 7 and a 99. When I add that up, I get 92. 92 gets multiplied now by 3. 3 times 92 is, I think it's 276. Wow. Boy, these numbers got out of control very quickly. 276 plus 0 is 276. And finally, my last column, to get the number, I got to take 3 times 276. Oh, my Lord. I'm going to do this on the side. 276 times 3. 828. Wow, 828. So my last column has a 12. Right below that is 828. If I add that up, I get 840. That's my remainder. That's a huge number. All that matters is that number is not 0. Since it's not 0, my conclusion is x minus 3 is not a factor. Okay. So it seems kind of silly. It's only a yes-no answer, but you got to do a lot of math there to find the remainder to see if you have a factor. Okay, I wanted to do one more. I'm stealing example 5 on page 333. So you can go to page 333 and read their explanation, but I'm going to do it right here. It says, is x minus 5 a factor of x to the fourth minus 3x cubed plus 7x squared minus 60x minus 125? So again, x minus 5 is my factor. I would put 5 in my box. And my coefficients left to right, right next to that would be 1, negative 3, 7, negative 60, and then negative 125 Again, I would draw that line, give myself a little space below those numbers, draw a line, and then let's start that algorithm we've done a few times. Now bring the 1 all the way down below the line. 5 is my multiplier. 5 times 1 is 5. That goes just beneath my -3. I add down. -3 plus 5 is +2. That goes beneath the line. 5 times 2 is 10. I write the 10 just below the 7. 7 plus 10 is 17. 5 times 17 is 85. That gets written just beneath the -60. -60 plus 85 is 25. Finally, 5 times 25 is 125. That's written right beneath -125. If I add up that last column, I get a 0. I circle it. Hey, I got a remainder of 0. Therefore, what? It means x minus 5 is a factor, right? And of course, it's a factor because the remainder was 0.